One, two, three. One, two, three. One, two, three.
Hey guys, what are you doing?
Oh, hello. Got a friend over here. Who are you?
I'm Kevin.
Oh, that's nice. I'm Yoav.
I'm Matt. I guess we ought to play a new game, huh?
What do you suggest?
How about some blackjack?
I could do that. I'm a
Yeah, sure.
novice. I'm a novice, so let's play for low stakes, okay? Like say $1,000.
It's a deal.
All right.
Let's see who wins.
All right, deal me in.
Want a card?
Okay, hit me.
What are the rules again?
Well, you try and get to 21. Anybody gets to 21 wins. If you go over 21, you're going to lose.
Oh, I see. I don't know. I guess I'll
you want
save.
a-
No, I guess I'll
just
save
stick?
what I have.
I'm going to take one more. I'm over.
All right, I'll stay.
So what happens now?
Well, you guys figure out who's got the most.
All right, I've got 19, Yoav.
Oh, what do you know? Look what I got. I got 21.
Ah, blackjack.
Wait, I think there's some other people watching us here. We ought to introduce ourselves a little bit more formally.
All right, I'll start. I'm Kevin. I'm an associate professor of computer science at the University of British Columbia in Vancouver, Canada. My research is on artificial intelligence, game theory, electronic commerce, and algorithms.
I'm Matt Jackson. I'm a professor of economics at Stanford University, and I do research in game theory and social networks and a variety of microeconomic topics.
And I'm Yoav Shoam. I'm also a professor here at Stanford. Like Kevin, I'm also a computer scientist in artificial intelligence and electronic commerce and game theory. And we're here to co-teach the class on game theory. So maybe let's start by saying a little bit about what game theory is about and as importantly, what it's not about. So often when we think about games, we do think about things such as rock, paper, scissors, or poker, or sports games like soccer and baseball. But really, game theory is about all kind of strategic interactions among self-interested agents, including those frivolous ones, but also much more serious ones. Matt, you're an economist. Tell us more about serious games.
Sure. Game theory has become a really essential tool to understanding a lot of different interactions, anything from auctions to people's behavior in financial markets, to even to international conflict, to understanding political interactions. So it's become an essential part of any social scientist's toolbox. And indeed, it's actually used even beyond that. So things like biology, predator-prey games, a whole series of things. So it's really a fairly widely applicable thing in any situation where there's competition, strategic interaction. So there's a lot to cover here.
That makes sense. But now, Kevin, you and I are computer scientists. What are we doing here?
Well, these days, game theory has become a really hot area in computer science, basically for two reasons. First of all, computers are increasingly a way of bringing people together, and that means we have to think about how people interact when we bring them together. And that's true whether you think about networks, keyword auctions that form the basis of almost all of Google's revenue, peer-to-peer file sharing systems, or consumer sites like eBay or TripAdvisor or Yelp. To understand how any of these systems work, we really have to think about how their participants are self-interested and how those interests drive their behavior. The second thing is that the sorts of economic settings that game theoretic economists like Matt study, as they scale up and get bigger, they start to encounter computational dimensions. And to make the right kind of sense of those and bring these things into practice in the real world, it's really necessary to think about them in terms of algorithms, complexity theory, and artificial intelligence.
So let's speak a little about our class. First, let's set expectations. For all these potential applications we're discussing, our class would really be very fundamental, about the very fundamental modeling tools here. We will not attempt to advise people on how to use it really in the real world in any direct way. We'll only use examples by way of illustrating the the formal constructs. So let's speak a little about the syllabus.
Sure. So the course will run about 7 weeks. It's really an introductory course. It doesn't presume that people have any experience in game theory before. It'll assume a tiny bit of background in probability and calculus, but generally it should be accessible to a pretty wide range of people. Our intention is just to show people how our game's structured, how do we think about strategic interaction between people. We'll start with equilibrium notions, we'll talk about incomplete information, we'll talk about timing, repeated games, we'll also talk about coalitional structures. So we have quite a bit of things to cover, but it should be a very fun course for it.
Kevin, you want to speak a little bit about some of the mechanics and what people need to do and so on?
Sure. So there's a lot to this course besides just the videos. Some of these things are going to be graded and others not. So on the graded side, there are 3 key components. The first are quizzes that happen after the videos that you can use to test your comprehension. And if you find that you get some of the questions wrong, that might indicate to you that you should go back, see the video again, and make sure that you know everything you need before you proceed to the next material. The second element is discussion boards, which you can use to ask questions about parts of the course that you're finding confusing, and also to raise logistical questions about the course. And those discussion boards will be answered by other participants in the course, by teaching assistants, and also by Matt, Yoav, and me. The third element is lab exercises, where you can optionally play some of the games that we actually introduce in the course, see how you would reason in these games yourself, and then we'll have chat rooms as part of the labs where you, in real time, you can actually talk to other people from the course, share your experiences about what you learned, and see what they have to say. On the graded side, we'll have weekly problem sets, which will be sort of like the quizzes, but in a bit more detail. They'll give you a chance to show what you learned from the material in that week, and we'll have a final exam that will cover the whole course. Each of these you can take only once, and as I said, they'll be graded. We'll use that grade as the basis for your certificate of completion. So if you get all the way through the course, you'll get a certificate that's signed by all 3 of us.
So, and that will be a total of about 7 weeks, as we said. We should also mention that this is a very large class. There's many tens of thousands of students here. So we will do our best to be clear in our presentations, but a lot of it will involve help among the students themselves. So there are online forums, and they're an essential part of the class. You really want to form study groups to consult each other on the problem sets, on the lectures. We do have TAs that will monitor the forums, both TAs at British Columbia and at Stanford, as well as community TAs that have stepped up. But at the end of the day, it'll only work if, as a community, we all work together. Please, because of the large numbers, don't send us personal email. It's not that we don't like to speak to you, we just won't be able to handle it, so we won't be able to respond. Similarly, there is the class website on the class website, as well as on the social media. If you want to kind of follow us personally on our personal sites, by all means, but no, please, friend requests and so on. Again, the numbers are so large we won't be able to respond. This is really going to be a fun class, isn't it?
Oh yeah, I'm looking forward to it. Should be a great time.
I had a lot of fun with that previous game.
Yeah, and actually I think it's time for Kevin and I to win some money back.
Well, let's see how good you are.
Okay.